Hello, my name is Lauren Gunter, and today I'll be going over my final project where I investigate the ethics of criminal risk assessment tools. So ever since the early 1900s within the criminal justice system, risk assessment has been used to identify the risk of a current defendant. In modern times, algorithms have been drafted to aid the court in making fair, consistent decisions about individuals and predicting the risk of a person. I decided to undertake this project because of my interest in how AI is involved in industries that aren't normally thought of as technical, my naive understanding and the potential flaws of the current justice system, and the desire to increase my knowledge in what impacts this system and how this system impacts other areas. In using these algorithms, several problems have risen. Currently, there is no regulation in choosing an AI model or transparency from these companies that make them, so the general public has no idea how these instruments are being made or used. In using these models as well, people in charge of making decisions about an individual will become further dependent on using AI, even though these algorithms might not have all the data about an individual. Finally, there's already been discovered bias in an existing instruments, such as how a model named Compass has been found to falsely discriminate based on race. Many of these models are also available for public use and have spread lots of misinformation, like in the figure shown to the left, which shows a student using a model to predict crime in the area of Boston and how this has a distinct correlation with race. With these incoming problems, there has been an increasing desire to measure the fairness of a model. Since many models' proof of fairness is based on mostly if their results are fair, I wanted to instead emphasize on if a model's procedure was fair. In doing so, I would train my model based on fair parameters. Also, I decided to instead have a model that would predict the crime rate and a geographical area, since any AI model that I were to create would not be nuanced enough to measure individual data and would more likely misappropriate this data. For my code, I decided to use a support vector regression model because it outputs percentage likelihood instead of classifications. For my training data set, I found one widely used in this field, which is named Crime and Communities, and contains 125 statistics from around 2,000 cities in the US collected from the census in 1990. There still exists some bias in this data from the statistics in cities chosen to be recorded. Some of the interesting statistics had to be excluded, like police operating budget and police overtime work, since not enough of the cities had released this data. I wanted to evaluate this type of model with different training parameters, so I iterated through my process 3 different times. The first iteration involved training the model on all parameters. The second filtered out all unfair parameters, which were chosen based on qualitative research to be parameters that included gender, age, and race. And the last iteration uses 6 parameters that were seen to have the most correlation with the prediction that were also deemed fair. 25% of the data was also reserved to calculate the accuracy of the training models. Each iteration was put through a program that was designed to measure the correlation of the training parameters to prediction percentages, which is titled Fair ML, and it meant to be used for black box algorithms. These iterations all had about the same parameters, and these iterations all had about the same parameters that had the most correlation, and these parameters weren't really deemed unfair. Even in iteration 1, these parameters had the most correlation, and parameters that were deemed unfair did not have too much of a significant impact. All iterations had about a 60% accuracy. There were also some parameters that weren't deemed unfair by the aforementioned research, but could still be considered as having bias, and they weren't removed from the parameter list. This project further shows how there is no way for the public to know how an instrument is created or trained unless creators release this information, and that it is difficult to determine what parameters are truly fair when determining risk for individuals or geographical areas. Tools like these geographical prediction algorithms can affect individuals by having indirect effects on the amount of policing in these areas, and that geographical location could potentially be used in evaluating individual and an instrument. Instruments could potentially be used in the future, but for now there should be a standardized algorithm used in evaluating individuals or geographic areas throughout the US to increase the data used in creating them and decrease the dependency on them. Additionally, the companies charged with creating these should be incentivized to release algorithm creation data. This project could be taken further in a couple ways. The first being to take data from a smaller but contiguous region instead of data from isolated cities, since area of the US could have an implicit effect on these statistics, and because it would be more efficient to diagnose the resulting fairness of the predictions. It would also be nice to look at more parameters and to be able to do more research on what could be deemed unfair parameters by experts and the general public. In addition to evaluating the procedural fairness, it would also be adequate to measure the result fairness of the same model to see how fair it is in the decision process. Thank you.